Let's check in on the statement of work. In Summary Task 4, perform impact assessment. SpaceX understands there are some unavoidable environmental impacts associated with expanding Starbase. Increasing the number of vertical launches will negatively affect sensitive wetlands that stabilize the shoreline and provide habitat for wildlife. Rocket launches are also very loud and can negatively affect nearby residences and businesses. According to the draft environmental assessment SpaceX submitted to FCC, ignition of the Starship Super Heavy rocket engines will generate a heat plume with a maximum temperature of 90 degrees Fahrenheit within 0.6 miles of the orbital launch pad, enough to injure or kill wildlife in the surrounding wetlands. Ignition of the Starship Super Heavy rocket engines will also generate noise levels greater than 115 dBA within 3 miles of the orbital launch pad, the highest permissible noise exposure for nearby residents and businesses. Scientists have developed sophisticated heat plume and noise level models to determine how vertical rocket launches impact the surrounding environment. You'll perform a simplified version of these analyses to measure the acres of wetlands and number of buildings impacted by a Starship Super Heavy rocket engine launch. In Summary Task 4, we'll perform the impact assessment. First, we'll perform a wetlands impact analysis. Second, we'll perform a noise impact analysis. And then last, we'll update our layer names and symbology. Back in ArcGIS Pro, we'll start with the wetlands impact assessment. Activate the analysis ribbon, and in the geoprocessing group, click on the Tools button. This opens the geoprocessing pane. I'm going to search for the pairwise buffer tool. And right-click the pairwise buffer item and select Locate. This locates the pairwise buffer tool in the toolboxes, which is found in the Analysis toolbox in the pairwise overlay tool set, and there's pairwise buffer. I'm going to click it to open it. I want to set the input features to the orbital launch pads. We're going to buffer both pads at the same time. The output feature class, I'll go ahead and click on the Browse button. And I want to browse to my impacts feature dataset. And we're going to call the output launch_heat_plume and click Save. Now the distance is going to be 0.6 statute miles. And there it is. We'll leave the method set to planar because this is a locally projected coordinate system. And the dissolve type, change it to dissolve all output features into a single feature. Go ahead and click Run. This creates the buffer. In Catalog in our Project Geo database, you can see the Launch Heat Plume feature class, and it also listed as a feature layer in the Contents pane. I'm going to right-click and zoom to Layer. And there you can see the buffer. It's not quite concentric. It's a little bit more oblong because it's buffering the two launch pads. Now I'm going to click Back. And in the same pairwise overlay tool set, click on Pairwise Intersect and set my input features to launch heat plume that intersects the surrounding wetlands. I'm going to browse for my output feature class. Again, put it in the impacts feature dataset. I'm going to call this wetlands_impacted. Accept the remaining default settings and click Run. This intersects the launch heat plume geometry with the wetlands geometry. Go ahead and close geoprocessing pane. There you can see my wetlands impacted feature class and my feature layer in the contents pane. I'm going to right-click the wetlands impacted feature layer and select Attribute Table. And there you can see it combined both the launch heat plume attributes with the wetlands attributes. And we're going to use these attributes to generate our summary statistics. So for the unique values in wetland type, we want to calculate the acres. Now the shape length and shape area were automatically updated when the geometry changed, but not the user-created field acres. So I'm going to right-click the acres field and select Calculate Geometry. That's going to use the shape polygon values to calculate the acres. I'll set the property to area and the area unit to international acres. And then the coordinate system I'm going to set to the same local coordinate system we've been using. Go ahead and click OK, and you'll see that the values actually updated in the acres field. And now for every unique value in wetland type, we want to sum the total acres impacted. So I'm going to right click on the wetland type field and select Summarize. That opens the summary statistics window. The input table and output table we're going to leave set to the default. We'll set the statistics field to acres and the statistics type to sum. And so for every wetland type, it's going to sum the acres. Go ahead and click OK. If you look in our Project Geo database, you'll see it created the Wetlands Impacted Statistics standalone table and also listed it at the bottom of the contents pane. I'm going to open the standalone table. And there I'll find for every wetland type impacted, the sum acres of that wetland type that was impacted. And it's that number that you want to note because you're going to use it again when you write your executive summary and when you finalize your map series for this project. Now I want you to return to the statement of work and complete the noise impact analysis on your own, and then I'll rejoin you at the end of task 4B. All right, at this point, I've completed my impact assessment. If you look in the impacts feature dataset, there's my buildings impacted by the launch noise contour, as well as my wetlands impacted by the launch heat plume. Now I want to update the layer names and symbology in the contents pane to make them a little bit more user-friendly. So I'll start with the layer names and replace the underscores with spaces. So orbital space, launch space pads. I'll do the same for buildings impacted. Also want to add some clarifying information. So for example, get rid of the underscores for launch noise contour, and then I'm going to append to the end, open parentheses, 115 dBA, close parentheses. Continue renaming all of the layers in your contents pane, giving them user-friendly names. All right, we also want to update the symbology to raise them on the visual hierarchy. So for example, click on the building's impacted symbol patch. And for the properties, I'm going to set the color to a red fill and a 0 outline width. For the launch noise contour, I'll click on the symbol patch and switch the symbology pane to the layers panel. Select the solid stroke, uncheck the fill, and change the solid stroke color to red, the width to 1.5, and then I'm going to expand the dash effect, and under dash type, select the first dash type. I'm going to continue updating the symbology again, raising and lowering layers on the visual hierarchy as needed. Now let's update the symbol patches so they better reflect the features they're representing. So for example, if I select the building's impacted feature layer and click on the symbol patch dropdown in the symbology pane, I'm going to select the building symbol. For launch noise contours, the circle, and go ahead and customize the symbol patches as you like. The last thing I want to do is to tone down my layers. So I'm going to select multiple layers that I want to tone down, go to the feature layer, context sensitive ribbon, and set my transparency to about 50%. All right, that looks pretty good. Go ahead and close the symbology pane, reset the contents pane, and save your ArcGIS Pro project.